Okay, so in front of us we have a Vega 64. This is the reference model. If you've come across my channel or my videos hoping to get your graphics card repaired by either me or someone like myself, I should note that I now have a Discord server with the contact details of graphics card repair experts living in the US, UK, Germany, Indonesia, and now Israel. Anyways, so like all the broken cards we get, we want to first start by checking for a short on the base voltage rails. So I have my multimeter in continuity mode. If I probe something connected to ground, like ground itself, my multimeter beeps. Okay, so to start with, we're going to check 12 volts and 3.3 volts at the PCI Express slots. So to check 12 volts, we start at this, we can check any one of these first three pins over here on the left, and we're perfectly good. And to check 3.3 volts, we start this notch and we go 4 pins left. Perfectly good. Okay, now we want to check 12 volts at the two external 8 pins. We can get away by just checking these two inductors here. So checking the one up top, perfectly good, and checking the one at the bottom, perfectly good. Okay, so now we want to go to resistance mode and check the voltage rails generated by the card itself. Okay, so to start with, we want to check 5 volts. So I should note that Vega has two 5 volt LDOs. So the first one is on the front, and in particular, it's this top right pin. And as you can see, we have 3.4 kilo ohms, which is perfectly fine. The other 5 volt LDO is actually on the back. So it would be this component here, and in particular, it'd be this pin over here. Checking that 5 volt LDO on the back, we have 3.2 kilo ohms, again, perfectly fine. Okay, so to start with, we want to check the PEX rail, which is over here, this one. So this is usually around, I would say, 13 or so ohms, and we have 14, which is perfectly fine. Now we want to check 1.8 volts. 1.8 volts is found on an inductor here. 1.3 kilo ohms, perfectly fine. Now we also want to check the memory controller up top over here. 19 ohms. Again, perfectly fine. And finally, we want to check the HBM memory. This is typically around 35 ohms. And as you can see, we have 35. So since we're not short on any voltage rail, we can go ahead and power on the card and see what we're missing. Okay, powering on the card. We're going to start with the PEX rail. Actually, start with, we're going to check 5 volts, both of them. So checking the 5 volt rail at the front. Yep, 5 volts. Checking the 5 volt rail on the back. Yep, 5 volts as well. Now, checking the PEX rail at the front, 800 millivolts as it's supposed to be. Now, and going up to 1.8 volts, 393 millivolts. So this is our problem rail, and it's actually kind of similar to, reminds me of a video I saw. If you don't know, this is similar to the problem that Eli Tech had in his one Vega video. So hopefully it's not too similar. Anyways, going up, so because we're missing 1.8 volts, I expect that we'll be missing both the memory controller, the V-core, and also the memory. Yep. Okay, so as you saw, we're missing 1.8 volts. We only have about 400 millivolts, and I should note that the way it works on Vega is that this this here is actually a MOSFET, believe it or not. Instead of being a buck converter, it's actually just a plain old MOSFET, and the driver for this MOSFET is on the back. So this over here. So the MOSFET itself is an NTL D4901, I believe. Whatever it is, I'll link it in the description. And the driver for this MOSFET is actually on the back. And this is an NCP5230, I believe. Anyways, so I'm going to start with the driver on the back and not the MOSFET, just in case, you know, this is exactly Eli Tech's Vega. So anyways, let's go over to an overhead view and try to determine what's gone wrong. Okay, so as you can see, we have a microscopic view of our driver for the 1.8 volt MOSFETs. So to start with, we're going to check VCC, VCCP, and the bootstrap, as those are our power pins and they need to be in perfect working order. So I have my multimeter in continuity mode. If my red probe touches something connected to ground, my multimeter beeps. Okay, so to start with, we're going to check VCC, which can be found on this capacitor here. You can tell by the trace. And as you can see, we're perfectly good. Okay, so after that, we want to check VCCP, which is the first pin here, and they connect to these two capacitors here. So we have, well, as you can see, we have a short, and on the other side, yep. So we have a short, and in fact, it's a 0.8 ohm short. So I guess finally, since we now know what's wrong, we're going to check our bootstrap, and no short. Okay, so we have a problem with either these two capacitors or this driver. So unfortunately, I have a suspicion this is going to be exactly the same as Eli Tech's Vega 64. So we're just going to start by, actually no, we'll do this the proper semi-scientific way. So I'm going to hook up my power supply, and we're gonna see which component burns away a bit of alcohol when we supply current to our shorted power rail. Okay, so first things first, we want to be pouring some alcohol onto our suspected shorted components. So here we go. Okay, now I have my black probe connected to my power supply over here, and it's set to 2 volts in this case. VCCP will be much higher than 2 volts, so we should be safe. Okay, so as you saw, it seems like our problem component is unfortunately just this capacitor here, just like Eli Tech's video. So let me go ahead and remove it, and we'll see if the short is gone. Okay, so as you saw, I removed the capacitor in this location. If we now check for short, you'll notice that it's gone. And if I check the resistance in resistance mode, 11 kilo ohms or so. So that's definitely not shorted to ground. And in fact, if we look at the capacitor itself, as you can see, when we look at our capacitor, we can actually see a crack right in the middle. So the correct value for this particular capacitor is 10 microfarads. Okay, so despite what you saw, the card is not actually fixed. So it can technically boot and you can run for a couple hours, but like I said, it's technically not fixed. So I haven't been quite as thorough as I should have been. So originally I just left it as is and thought it was good, but in hindsight I realized I've actually missed something. So let's actually go ahead and check the voltage on VCCP where our shorted capacitor was. Typically this is supposed to be 12 volts on a working card. However, on this card you'll notice that we only have 10.9, 10.8, and dropping actually. And that's, yeah, far too low. Okay, so as mentioned, I've actually made a bit of an oversight. So like I said earlier, or like you may or may not have seen, VCCP is supposed to be 12 volts. The reason why we don't have 12 volts is actually due to the fact that in a lot of these graphics cards, when they pull, let's say, 12 volts for a buck converter or a driver, they often pull it through a resistor. And in particular for this card, this VCCP pin connects to this resistor here. The thing about these Vega cards that, let's say, have dead capacitors at VCC or VCCP is, or even just a dead driver, is that they will often kill these resistors, but they often don't kill them straight away. Instead, they damage them, and over time, they get significantly worse until the voltage keeps dropping and the card becomes undetected once again. So anyways, if you don't know, this resistor is supposed to be 0 ohms. So this one up top supplies VCC, regular VCC, and as you can see, it's actually 0 ohms, but this one, we don't have continuity. And if I check the resistance of the resistor itself, we have 43 kilo ohms. So this used to be about 360 ohms about 10 minutes ago, and now it's 42 kilo ohms. So yes, we have to replace the resistor as well. Okay, so as you can see, the Vega is currently running game and doing other Vega things like being very loud and running with a hotspot temperature of 100 degrees Celsius. Anyways, just as a brief summary before we end the video, the card itself only had a shorted capacitor, but the shorted capacitor ended up not being the only problem. So anyways, as you saw, we had a dead capacitor, 10 microfarad capacitor on the VCCP pin of our 1.8 volt driver. And this is supposed to be 12 volts if you don't know. So after we replaced this, or at least after I replaced this capacitor, the card originally worked without issue for at least a couple hours, and I put it back together and thought all was good. However, I couldn't but help notice that it seemed a little suspicious, because as you may remember, when we did our initial resistance check, we did not have a short on the 12 volt rail, despite the fact that this capacitor technically shorted 12 volts to ground, or at least a portion of the 12 volt circuit to ground. So what had happened was that unfortunately when this capacitor died, it pulled so much current that it also killed this resistor over here. So this resistor was supposed to be 0 ohms, but unfortunately after the capacitor died, this then jumped to 360 ohms. Which was still low enough that the card worked fine without issue for, again, like I said, a couple hours. But as is typical with damaged resistors, it started degrading at an accelerated rate, and eventually this jumped up to 42 kilo ohms, as I mentioned on camera. And by the time it got to 42 kilo ohms, instead of, let's say, passing 12 volts to VCCP, it only passed 6 volts at its very lowest. I think the clip that you'll see, it shows 10.9. So anyways, the solution, of course, was to replace this dead capacitor, which is 10 microfarads, and also replace this dead resistor, which is supposed to be 0 ohms. I should note that the failure you see here is actually rather typical, in my experience, for Vega cards with, let's say, a short on either VCCP or VCC. Typically speaking, again, like I said, in my experience, you can replace the capacitor and it'll work fine for at least a couple hours, but then eventually the resistor that bridges 12 volts to either VCC or VCCP degrades to a point where it can no longer pass 12 volts in its entirety, and the card reverts back to being undetected. But anyways, I hope you learned something watching this video. If my videos on my channel has helped you out, consider becoming a patron, link description, or buying something from Teespring, or even just sending a PayPal donation. But or just using an Amazon affiliate link. But anyways, like I said, I hope you learned something in this video, and hopefully I will see you in the next one.